morning, folks. Rosendo from LH here. Thank you for joining us at Global Hack Week. I hope y'all have been having a great time out there. Today, we've got a special treat for you. Our friends from Auth0 are rolling on with their promotion. So it's going to be another great workshop where we learn how to secure our RAG applications using Okta FGA and LlamaIndex. So it's going to be a good one. If you're into RAG applications, as you might be aware of during AI ML week, it's gonna be this is gonna be a perfect workshop for y'all to kind of pay attention to and learn some new skills. We've got Deepu from Okta, I believe, who is going to be joining us today. So please give him a warm welcome. Welcome, Deepu.
Hey, thank you. Hello, folks. Hope you're all doing great. Let me share my screen to begin with. Awesome. So yeah, welcome to the workshop. I hope this is useful for you all. Especially RAG agents are all the craze now. Everyone is building agents. For various stuff like integrating with other tools or services and stuff, autonomous agents. You can also do RAG as an agent. So we'll see how you can use LlamaIndex to build RAG applications which are more agentic, not your standard RAG pipeline ones, but more agentic ones where you can you can convert them into more complex graphs and stuff. We'll go through details and stuff on the way. So a little bit about me. I'm Deepu. I'm a huge open source guy. I'm a co-chair of JHipster. It's a rapid application development platform on the Java side. I'm a Java champion. I have created a bunch of open source tools, mostly in Rust. I'm also a huge fan of Rust. I have created a Kubernetes dashboard called K-Dash. UI for decoding JWTs and stuff like that. I'm also a developer advocate at Okta. I mainly focus on AI security these days. I'm also a polyglot developer working with mostly Java, Rust, Go, and TypeScript these days. But yeah, I'm also author, speaker, all that stuff. You can find me on some of the social media as shown here. If you want to follow me or get updates and stuff like that. So let's begin. So I have a workshop for you today. I think you will see the link for the workshop directly on the screen. So it's a hosted workshop where you can follow along, copy code from there, try it on your own and stuff like that. So you can see it as a banner, the workshop. You can also scan the QR code here on the screen if you like. So let's begin. Awesome. So this is the workshop. You can there is a toggle on the top right corner, so you can switch it into either like a single page guide, or if you want to do step by step, switch it into a lab mode. I would suggest switching it into the lab mode, so we can go step by step and you can follow along as I progress. So one of the first things is why use LlamaIndex, right? Or even before that, why even worry about securing your RAG applications and stuff? So one of the biggest security concern when it comes to LLMs and RAG-based systems is sensitive information disclosure. That is, if you are building a RAG application, you most probably would be using an LLM that is not local. I would assume most probably it's going to be some sort of hosted service like OpenAI or Google Gemini or whatever. And when you have these LLMs integrated into your integrated into your retrieval augmented generation systems or RAG systems, you should be worried that the LLM might have access to all your data, and you don't want your LLM to have access to all the data that you have. So in a typical RAG system, you might be connecting that system to your internal database or in your internal CMS or your document store or your company's document store, sensitive documents, all sort of stuff, right? You don't want these to accidentally leak into the LLM, because regardless of what every LLM or every AI company promises, LLMs are never 100% secure. You can never guarantee that a large language model is bulletproof or secure enough that it will never disclose sensitive information unintentionally, because you can always manipulate an LLM to reveal information which might be of sensitive nature and stuff like that. So with all these privacy concerns and these kind of unique security issues that are in the LLM or AI world, Gen AI world, um, it is a good idea that we have some sort of or some a layer of security between our data and between the LLM, so that you never let the LLM get all the data directly and decide what to use or not. So instead, you decide what kind of data your LLM sees when you're querying for certain data, and you decide what you filter out, what kind of access control you want to introduce, all this stuff. So that is the main purpose that we are building LLM or so RAG applications with a security layer in between. So why do you go with LlamaIndex, right? There are many frameworks out there. We have LangChain, you have the Versal AI SDK, you have Crew AI, you have a lot of frameworks out there to build these kind of applications. So LlamaIndex is one of it, and it's quite popular. It's quite easy to use. So I would consider LlamaIndex and LangChain very close to each other, quite easy to use. Supports Python and JavaScript languages, have SDKs for that. So yeah, so I'll just go with LlamaIndex for this one. Uh, if you want to go with LangChain or something, won't be a lot of difference in how you implement stuff. But let's go with LlamaIndex for this one. So we'll be using the JavaScript version, which is llamaindex.ts, and we'll be building Node.js application as an example. Um, so you have certain prerequisites if you want to follow along. I would suggest at least Node.js v20. I would suggest also using VS Code or Cursor or whatever is your favorite IDE. You also need to create an Auth0 FGA account, which is free. So you can click on this link to create an FGA account. So if you already have an Auth0 account, when you click on this, you would automatically get signed up, and you will get a FGA instance. But if not, sign up, do this part, and we'll be using OpenAI as the LLM, but you can also use something else if you like. If you have something running locally with Olama, you can also use that. But for convenience and for ease of stuff, we'll be using OpenAI stuff. You can sign up to an OpenAI account and create an API key. So you would want an API key. So if you're following along, I suggest you do these two steps. So create an FGA account, create an OpenAI account, and get an API key. So with that, we can start. So I'll talk a little bit about the dependencies that we are going to use. So let's see. So we very minimal dependencies for this particular example, right? So we have we'll be using a TypeScript node application. So TSX and types node to make development easier. So these will be dev dependencies. Other than that, we use 3 dependencies. We have 4 dependencies actually. So we have .n, so that you can load environmental variables to your application. We use the OpenFGA SDK, so that we can talk to Auth0 FGA. I'll give you a short introduction of why we are using Auth0 FGA a little bit further down the line. Then we also use a very alpha-ish version of one of Auth0's AI SDK. This is something that we are currently building, but we'll be using that for this demo. And finally, LlamaIndex. So these are all the dependencies that you would be using. And few more things that you would need for this lab is 2 files. So if you look at the link here, it links to these 2 files. So I suggest you download these 2 files as well. So it's nothing too complex or anything, just 2 markdown files. One talks about certain private details of a fictional company called Zico. It has revenue details and stuff like that. And the other one is some public information about the same company, like what technologies, products, and service they have, and stuff like that. So these two files. So I suggest downloading these two files by following that link. So let's begin. So yeah, in your whatever, you create a new folder, open that new folder in your favorite ID. So let's create a new npm project. We can have whatever name, doesn't matter. Doesn't matter. Description for demo purposes, so it doesn't matter. Entry point will be index dot. No, I think it can be index.js because we'll be compiling on the fly anyway, so it can be index.js. I mean, test command. We are not going to write any tests for this demo, so you can leave it empty. Git repository. We are not going to publish it. Empty keywords doesn't matter now. Doesn't matter. License, you can keep it the same. So you can keep all of this the same. You can also just do this because we are not changing any values, so it will create a base npm project. So next up, let's
Hi,
in
Deepu. Sorry to interrupt here. Do you
yeah,
mind zooming in just a little bit on the screen?
this one.
Just any of the screens, especially in the IDE, so folks can see.
Okay.
Thank you.
Okay, yeah, sure. This one, is this fine?
It's
This
perfect.
one,
Thank you.
and the IDE as well.
Mhm.
Let me. Is it better?
Yes, much better. Thank you so much.
Cool. Thanks for telling me. Let me adjust this a bit. I think this might be better for commands and stuff. So I'll just use this and keep this just for the code. So that's it's easier. Cool. Next up, let's install TypeScript support. So let's install TypeScript. It's installed. Next up, let's also install .10 OpenFGA SDK and the Auth0 AI SDK. While it is installing, let me copy the LlamaIndex one as well. Yeah, this one, that's quite a lot of stuff being installed, especially if you're installing something from Git repo. It takes it takes a while. I think this would be enough time for us to talk about certain stuff. Okay, why FGA, or what is FGA? So let me give you a short introduction. So Open FGA. So OpenFGA is open source project from Auth0. So it has something called relationship-based access control or fine-grained access control. I don't know how familiar you are with access control mechanisms, but generally in software access control, we have two primarily or widely used system. We have something called attribute-based access control, and we have something called role-based access control. So role-based access control is what you normally see in web applications, all these kind of stuff. So it's very typical where a user has particular role, and your permissions are decided based on the role you have. You might be an admin, you might be a manager, you might be a HR or whatever, and the scopes or like the things that you can do is decided based on that role. And then we have attribute-based access control, which is not widely used on web applications and stuff. These are more used on say infrastructure related things like Kubernetes, for example. In Kubernetes, you can do attribute-based access control and also role-based access control. So these are the widely used access control mechanism, but they have a limitation. These role-based or attribute-based are limited in how granular you can go. For example, with role-based access control, you can do some sort of granularity, but The moment you want granularity at the level of objects, for example, you have a database, you have a table, right? If you want access control to be uh, at an individual row of the table, then that becomes harder with role-based access control. You can do it, but it becomes very complex, very cumbersome. Managing it becomes very cumbersome. Implementing it becomes very cumbersome. Similarly, if you have an object-based database like a JSON object-based database or something, and if you want to have relationships that are very fine-grained, like very fine-grained to an individual object or an individual property level, becomes very difficult to do with role-based access control. An example of some that would be Google Drive, right? A system like Google Drive or a CMS or a document-based system, right? You need to have access control per document, right? If you are uploading a document, you are the owner of the document. You can share that document to certain people. You may be able to share a parent folder with certain people. You might be able to share just one object from a folder with certain people. So there are all these kind of fine-grained access controls that you can define in a system like Google Drive or a document store. So that is an example of relationship-based access control, because you're defining access control based on an actor or user's relationship with an object in your database. So OpenFGA is designed to support that kind of a relationship model where you can define fine-grained access control between actors and objects. So OpenFGA is the open source version. You can run it locally with Docker. You can host it on your own, and you can use it as well. We also have a hosted version which is called Auth0 or Okta FGA. So for the demo, I'll be using the hosted version because it's easier to get started with and all. But you can also run a local version if you want. But I assume that you already signed up to a free account with Okta FGA, so you can use that for this. Oh, sorry. Here. Cool. So we'll be writing the entire application in one file, index.ts. So let's see if, yeah, this is installed. Let me also install the LlamaIndex dependency. Let it cook. Cool. I spoke about OpenFGA. If you have any doubts around OpenFGA or any of this, feel free to add comments. And after the demo, I'll go through the comments and I'll answer any questions you have or any clarifications you need. Okay, let's see. It's still installing. In the meantime, I think we can go ahead and start creating our application. So let's start index.ts. So this will be our main application file. Let's also go create a folder called assets and a folder called docs. It doesn't have to be the exact same structure. I just like to structure these like in this way. You can also just put the documents directly under assets. Doesn't matter. I'm going to copy the two files over. Wrong folder. Okay, I hope you downloaded these files, two files, the private doc and the public doc. So they are going to be in the docs folder. Let me see if LlamaIndex is installed. Yeah, everything is installed. So let's begin. So first things first, right? We are going to create async main function. No parameters, so it's going to be empty function. Let's call it main, and let's add some error handling for main dot. Let's run main and let's catch errors, and let's log our errors to the console. So let's log everything. This is the simplest kind of error handling because we are just going to, we're just demoing stuff, so it doesn't really must matter. Let's console log something to begin with. Okay, let's begin. So let's assume that the our application is going to have some sort of user management, right? So there will always be a user on context. So since this is a demo for us, let's hard code a single user for this particular context. So let's assume that in an actual application, this user will be provided by whatever is your authentication system. For example, if your actual application is authenticated using OAuth 2 with a identity provider like Auth0 or Okta, then this identity provider will provide the username or the user ID for you. Let's put that down. So first, we need to create a pipeline for our RAG application, right? And since we are going to build an agentic RAG, so there's a difference between standard RAG application and an agentic RAG. So a standard RAG application, you define a RAG pipeline, which is like sequential. So you get your documents, you put your documents in the vector store that is outside of the RAG pipeline. So assuming that you already have all your documents in a vector database, your RAG pipeline might look something like get documents from the vector store, add it to the retrieval chain using whatever framework like LlamaIndex or LangChain. So add the documents to the retrieval chain, then query the retrieval chain using an LLM. Right, that is a standard RAG pipeline. Whereas in an agentic RAG, you can define you can think of an agentic RAG like a complex state graph, right? So it can have nodes and edges. So you can define different nodes. So each node can be a tool that the agent can use. So one of the tool can be a retriever, like a query engine that retrieves documents from a vector store. That can be a tool. So there can be other tools, like another tool could be something that talks to Gmail and gets emails from there, or another tool could be something that talks to calendar, Google Calendar, and gets data from there. So you can have a lot of tools as nodes. You can have like a parent node that controls these sub nodes and stuff. So you can do a lot of complex stuff with an agentic RAG. So we'll be building an agentic RAG here with only one node. So it's a very simple state graph for this example. But first, we need to load our documents. So let's say documents is equal to await. So we can use LlamaIndex provides something called a simple directory reader. So we can use that. So let's use that and load data from our assets folder. So let's assets folder is in the root assets/docs. So this should load our documents. So simple directory reader can read vary type of documents like Markdown, PDF, CSVs, Google Docs, Word docs. So many different types of docs, and it can read the docs, and based on the size of the doc, it will create chunk them into smaller documents and everything, and it will return you a bunch of documents based on that. So since we are trying out a demo, we will load our documents in an in-memory vector store. You can also use an actual vector database like Pinecone or something like that, Neon or something like that, but we will do this in memory. So let's create a vector store index. So we ping, these are all asynchronous services. So we'll be using asynchronous stuff here. So let's create vector. Let's use the vector store index from llama index, and let's create them from documents, and let's pass the documents that we just read from the directory here. So that creates a vector store index. So here we are one, we are load documents from the sets folder. Two, we are docs to in memory vector store. Okay. So now we have a vector store with all our other two documents. So we have a data ready for our RAG pipeline. So let's first create an FGA retriever, something called an FGA retriever. So this is where we would use the Auth0 FGA or OpenFGA as a layer to filter documents from our vector store based on permissions. So let's first create a retriever. Let's call it retriever, or we can also call it FGA retriever. Let's call it FGA retriever, and we'll be using. We need to import stuff. So these are already imported. So let me first import FGA. So since this is still in a Git repo, you would have to import it in the specific way. You can also see that code if you go to the next page. There's also a visual representation of how the pipeline. But once I write the code, I'll go through this. So you can also copy everything from this file here. You have everything that I'm going to write here. But let's go through. So I have the FGA retriever. So I will go ahead and create a new instance. So create, and I need to pass an object. So let's take a look at the FGA retriever first. So the FGA retriever, of course, it creates an open FGA client. So when you instantiate a new FGA retriever, it creates a new OpenFGA client. So it will use credentials that you have stored in a .env file, and it will use that to create a new FGA client. So that means you would have to create a few credentials for that. We'll look into that later. So it will create a new FGA client, and it exposes certain methods for the LlamaIndex retrievers to use. So for example, so this is a retrieve method that internally LlamaIndex will look for in any retriever. So in our retrieve method, what we are doing is we are retrieving, based on the underlying retriever. So whatever LlamaIndex retriever it is by default using to retrieve. So in this case, it will be using vector store index retriever. So we use that, we call that, and get the nodes. So nodes will be the documents that it retrieves based on the query. So this is all before LLM, right? This is all before LLM gets involved. So it will retrieve, so it will convert your query into embedding. So it will convert your query into a vector form embedding, and it will compare that against your vector store, and it will retrieve every node that is similar, or every node that matches with that embedding of the query that you just did. So this is pre-LLM. So it gets the retrieve nodes, and then we iterate over the retrieve nodes. And for each node, we build something called a check. A check is built using the build query that you're passing to the retriever. So when you are creating the retriever, you will pass few things. You will pass a retriever instance, that is the base a retriever that is being used. So in this case, it will be the vector store index. Let's convert that to as retriever, and let's define a similarity so that it gets more documents, because by default it will only return a certain number of documents. But for this to work properly, we need to limit that to 30, because if you get more than 30, then the default OpenFGA or sorry, Okta FGA instance will fail with a rate limiting because there is a rate limiting of certain numbers. So let's do this. Another thing you need to do is define a build query. A build query is a query against an FGA database. So this is going to be documents, document, and you need to define a user. So in this case, our user will be hard-coded one. So user. Then we need to say the object. So object in this case, let's say presented with doc, and let's say document dot. Let's get the metadata from that. Let's look for the file name. And let's split that. We don't need the entire file name. We just need the name. We don't need the extension. So let's split out. The extension. Let's do that, and let's get the 0th item from that. What is wrong here? Oh, looks fine. Finally, we need to specify the relationship between the user and the object. So for this example, we want to be able to retrieve every object that the user has a viewer relationship with. So if the user is able to view an object, we are going to retrieve that. So this is the build query that we are defining. So once you have, so in this method, it will use this build query to create a unique check object. And yeah, it'll, there's further some steps here to dedupe so that, we optimize so there are no duplicate checks and stuff that. And then it creates a new map which contains all the checks that we created and we create a map of we created a new map with the nodes, the actual node, and the key used for the check so that we can retrieve them later. So once you have all these things, then we call check permissions, which is another method here. So in check permissions, we call the FGA client, and with the FGA client, we call a method called batch check, where you can check against a number of, you can do a batch check of multiple queries. So we pass all the check objects there. We say we need higher consistency and stuff so that cache is not used. And based on this, it will create a response, and the response will say if an object if an object is allowed or not. So based on that, we create a permission map. We return that here. And now we have the actual original retrieved nodes, and we have a permission that says which nodes have, for which nodes the user have access. So once we have these, we can filter the retrieve nodes based on these permissions. So whenever a particular node has permission true, we keep them, we filter out the remaining, and we return that. So when LlamaIndex uses this retriever, it will always only get stuff that the user has permission. We'll debug through and we'll see the actual how it works. So we have defined the FGA retriever. So let's continue. And create the actual LLM stuff. So now we need to convert, now we need a query engine because we are going to create a query engine tool. So let's create a query engine. Let's create query engine equal to vector store index dot as query engine. So we need to pass the retriever to be used. So let's say FGA retriever is equal to FGA retriever. So this creates a query engine, and now we can convert that to tools. So let's create an array of tools. You can have multiple tools, but we are only going to have one for this. So let's create a query engine tool, and we pass the query engine that we just created and some metadata. Metadata is you need to provide a name for the tool, and oops. And a description. So we have tools array. So you can add multiple tools here if you want. Like for example, if you also want to get some data from a live database for the as context, right? Because this tool will provide the data from FGA as context, which includes the actual data from a vector store. And if you want to add more data, like data results from a database or something else, like Gmails or whatever, you can add other tools here. So that's how you build an agentic RAG that uses tools. So now we are only defining one tool. So let's proceed with that. So now let's create our agent, constant agent is equal to new. So since we are using OpenAI, we use the OpenAI agent. LlamaIndex also provides, agents for other LLMs, so we can use any of those. So let's go with the OpenAI one. We have the agent. So now we have the agent created with which can use our tools. So finally we can query the agent. Let response is equal to array agent dot chat. So we need to pass a message. So let's say the message is show me forecast for. Let's do something even more simple. What are the products from Seco? It shouldn't matter. It should be able to figure that out. But okay, and finally, let's print this. Print the output on console. Response dot message dot content will be in this key. Cool. So we have defined our RAG application. Let's try running it. I don't think we defined our start method. So let's define our start method. We are using TypeScript, right? So let's do TSX index dot ts. That should do. Let's try. So it fails. Cannot find embeddings. Please set embedding model. This is because we haven't defined any OpenAI keys, and we haven't defined any of that stuff for the application to infer from. So let's proceed with our example. I hope you are here. You are started doing this started creating the index.ts. So let's quickly go through the flow itself. So we have the pipeline. So the pipeline uses LlamaIndex OpenAI agent. It uses Query Engine as a tool, and Query Engine uses FGA Retriever. FGA Retriever in turn uses the vector store to retrieve the data. So this in overall this becomes a RAG pipeline. So it's an agent that is using FGA Retriever as a tool. So when you ask a question, it goes to the pipeline. The query engine is going to use the FGA retriever, and then it in turn uses vector store to retrieve data. So whatever data is retrieved, FGA is used to filter out based on user permissions. It uses the FGA database to do that check. Once that data is provided as context to the LLM, the query along with context is passed to the LLM, and the LLM will answer question based on your query and the context it received from this tool. So that's the flow. So let's set up a FGA store and let's set up all our environment. So I hope you created an account in FGA. So let's go to the Auth FGA dashboard. So you would have to log in with your Auth0 account. Cool. So this is your FGA dashboard. You can see there are a few items here. You have Model Explorer, tuple management, developer mode, and settings. So first things, we need to create a client. So what you do is you go to settings, scroll down, look at authorized clients, and you create a client. So you give a name, whatever you like, MLH, MLH lab. Oh, sorry. And you give all 3 permissions and you create this. So it's going to give you store ID, client ID, and client secret. You can click continue. You don't have to copy it now. You can copy it from the next screen. So on the next screen, it is going to give you a bunch of data. So we need this. So what you do is once you create the client, you create a .n variable. So copy this, go to your thingy, create a new file with .n, and you put this stuff here, right? So then from this client, you copy all the details. So you need FGA store ID, client secret, and if you are in the US, you can skip these. But if you are outside of the US and if you chose a region that is outside of the US when you created your FGA account, then you also need these. So I'm going to copy this. EU1. So I'm going to copy this, and then I'm going to copy my store ID. I'm also going to copy my, I don't need the model ID for this. So I need audience, I need client ID. And I'm going to copy the client secret. So once I have these, my FGA sites should be set up. So this is done. Then you need to get your OpenAI key and add it to the OpenAI key part. I'm not going to show you my OpenAI key. I'm just going to skip that part for now. 1 second, I need to close. Okay, I need to. Now we go and create a FGA model. So with OpenFGA, you create a model that describes your relationships, as in like what kind of relationship model you have with objects and users. So we are going to create a very simple definition. So you go to your model explorer, and you did I create a new store? No, I will create this one. I'm going to use this store. Go to the model explorer, and it's the same thing, right? Yeah, so you create a very simple schema. So you have a user type, you have a doc type, and you define an owner and viewer for this. So it's simple as that. It's the simplest schema you could define. So you have your schema. Now we need to define tuples. So tuples are how you define you create access control in FGA. Once you have the schema defines the overall access control scheme, and then you need to add tuples for individual users so that they have particular permissions. This is like creating roles, right? So we need to create a public doc thingy. So let's go here. Let's go to tuple management. So I already have these. I'm going to delete these for demo purposes. So I already have user star. So star denotes every user. So for every user, we are saying every user is a viewer on public docs. So that is the only tuple that we are defining. So now let's go and test the application. I need to do certain things. 1 second. Yeah, I set up my stuff properly now. Okay, let's try again. Let's try to start. We again have an error. This is strange. This. Okay, let's try this. This is not required usually. Let me see if there has been some changes. LlamaIndex. Okay, it's using a new version. Okay, let's try that. I think we can use the GPT model. Let me look for the actual. I think it is called. Let's try the text embedding 3 small. Why does it complain? String is not similar to base embeddings. Okay, we need to see how settings dot embedding. Let's look up that LlamaIndex. Okay, we need to do the entire OpenAI embedding thing. Yeah, this was not necessary previously, but I think it is now. OpenAI. Was there a import? Yeah, it is there. What is the problem? Oh, new. Sorry. What is the problem now? Yeah, that. Hope it works. Nope, it doesn't. Cannot find embedding this settings embed model. Huh. Let me see if it was an issue with the version, because I'm pretty sure this was working. Hmm, let's see if this works. Nope. Huh, that is strange. Okay, I'm gonna revert back in PMI. Let's try differently. Let's try this. Let's try to do it exactly as how it wants us to do. Maybe this. No, cannot find embodies. This is what the documentation says. So, oh, I see. I see. I see the problem. My bad. My bad. I don't think this is required. We haven't loaded our .n files, so that is my bad. So I should have imported. I should have imported this. So you need to do this. You need to import .n config so that the .n file is loaded. And once the .n file is loaded, LlamaIndex will see that we have an OpenAI key, and it will automatically create OpenAI embeddings. So that is my bad. It should work now. Oh, no, I was too soon. Huh, maybe it is still required. Wait a minute. Okay, let's try again. Don't worry, I do have a working one. I just want to... Huh. Interesting. It should work. Why doesn't it work? So this is a working one that I have. Let me try it out. So one that I created earlier. It's in one of our open source repos. So let's try this out to make sure that maybe it's something that I'm doing. Probably I missed something. Let me just quickly check. I have everything. Maybe I need to do the .n beforehand. Let me try that. Just for posterity. Shouldn't matter in theory. Well, maybe it does. No, it doesn't. Let's go back. Let me make this bigger. Oops, too big. So this is the exact same application. If you see, it's the same stuff. We have all those same stuff. We have the user documents, vector store. I did define it here. Oh no, that's a wrong one. No, this is the correct one. Yeah, I surely didn't define any of that. Nope. Okay, let's try this. This seems to work, so I probably did something wrong. Let me see if... I'm just curious. So let me comment this out completely, and let me copy this, go back here, and try again. Nope. Something wrong with this one. What am I missing there? Uh, type module. Let's add that because it's different. We have main looks fine. What else are we missing? Dependencies. We have all the dependencies. Pretty much the same dependencies. Okay. Let's try again. Nope. I'm very curious. Let's try again. Let's try replace this entire thing. Did anyone have okay, do comment if you're having issues, or I see some comments here. Is there anything? I'm not seeing any comments. Okay, no, I'm just going to replace this and try again. Okay, node modules. Sorry, -r node modules npm I. It's going to take a while. Interesting. That should have worked. It does work here. You can see it did work here. See? Okay, let's see while that works. Let's continue with this one. It should be the same if you follow along. If you follow along, it should be the same. So I think you are in the test part. So we were testing with some. Wait. Okay, we were testing with the default query. So now let's try something that wouldn't work. So show me forecast for Zico. So while doing this, yeah. So when asking it to show a forecast for Zico, it says the document I have access to does not contain any specific information because I deleted a specific tuple. So I deleted a specific tuple that was granting access to the private document. So now let's try adding that tuple back in. So let's say for user one, for doc, private doc, let's say viewer. So once we add this tuple, and then we go back and rerun the same thing again, it should now retrieve and show forecast for Zico because now it has access to private document. And we'll also do a small debugging to see how that filtering happens. It normally takes a while. Yeah, now it has shown you the forecast. So let's debug this. Let's put a breakpoint in one of the. Let's put a breakpoint here. Let's have a breakpoint here and let's debug this. Okay, so we have debugging. So now let's go into the FGA retriever and let's have some debug points here. Let's have a debug point here. Okay, and let's continue this. So we have the agent and we started the chat. It should drop here when it calls retrieve. Ideally, it should drop there. Yeah, this one is still not working. I need to see why. It's technically the exact same thing. So tool output, not here. Oh, it didn't go into that. Let me use the local one to show you quickly. I think I'll use this local one here instead of the one. Yeah, let's use this one so that we can debug. Let's try again. It's the same file as the other one. It's just using it locally because sometimes debugging kind of gets stuck when you have a file in a complex node module structure, especially coming from GitHub and stuff. Kind of gets messed up. So let's do this. Yeah, let's have it here. And so now it has dropped here. As you can see, so this is the vector store index retriever that we passed. So the vector store index one. So let's see what it brings us. So it has retrieved 25 nodes. It has retrieved 25 nodes, and then we do the reduction. Let's see. So we get a permission map. So if you look at the permission map, we get two permissions there. So we have user one for public doc, the permission is true, and we have user one private doc permission true. So because of that, nothing gets filtered out. Everything is permitted, right? So you get the entire thing. But now if we go back and let's say delete this, and try again. Try again. Takes a while to instantiate and everything. Okay, yeah, so now let's see how many nodes we have. So again, we have 25 because the 25 from the vector store, right? So it is going to include, let's say, node metadata. So it's going to include the private doc, and it's also going to include the public doc. You may ask why 25, because we only have two docs, because it kind of chunks documents into multiple parts based on size. So the 25 is chunks of these two documents together. So now let's see the permissions. So now the permissions, we have user one private doc false, and user one public doc true, right? So when you use this permission map to run this filter, you kind of filter out all the private docs, and you end up with let's see how many. So we end up with a node. This is the intern one. Let's go to so let's look at the response. So we have 24 now instead of 25 because the private doc was filtered out, and all the other 24 are splits of the public document, because public document was big, so it was splitted. Private doc was very small, so it was not splitted. It was only one doc. If you look at the metadata, this is all public docs. Zero metadata. This is all public doc. So if you even look at the last one, it's going to be the public doc. It's a public doc. So the public doc is big. So it was splitted into 24, I guess, here. And the other one was 1. So that was filtered out. So that's how the filtering works. So the filtering happens pre a LLM. So once you have this result, this is passed to the LLM as context, and then the LLM only has access to those docs. So you are filtering pre LLM, so hence securing your data. So that's the entire thing. I'm going to look into why my specific sample didn't work. I'm pretty sure uh, I don't know. I'm pretty sure I messed something up. If I just copy paste from here, I'm pretty sure it's going to work. But anyway, I think we are out of time to look into that. I'm going to look into that here. So, is there any questions that I need to look in? I need to answer here. There is too many on the chat. So,
Adipu. Yeah, it
hi.
doesn't look like there were any questions specific to the workshop. There were folks,
Hmm.
jumping in and out asking about general global hack week stuff.
Okay.
But yeah, I mean, awesome workshop. Thanks so much. I know we're a little over time here, so
Oh
if you do have
yeah.
any questions out there, if you're watching from home, drop them now. But yeah, I mean, thank you so much for your time. Just
Thank you.
a couple of announcements from my end. You could check out the Auth Zero challenges. You're going to see the links rolling at the bottom below. If you want to rewatch any of the recorded content from Deepu's workshop, you could check us out on the YouTube channel, so you'll be able to see the recorded content there. I've also dropped the link for the challenges in chat as well, so be sure to check those out. We've got some interesting things for you to kind of engage more with the Auth0 platform. And yeah, if you enjoyed building authorization for your RAG applications, you know, definitely check out this workshop again if you want to implement any of those solutions on your side. Yeah, you can get everything from there. We'll also put up the link for the doc once again on the banner. And yeah, that's going to be it for today. Really appreciate everyone out there. Thank you so much for joining us. And Deepu, once again, thank you so much for your
Thank
time
you.
here. Really appreciate it. Great workshop. Really enjoyed the content myself following along at home. Yeah, that'll be it for today. We will see y'all in a minute. In the next, in about an hour from now, we'll have another workshop for y'all, and then also stay tuned for Global Hack Week Daily, so you can get your daily updates. Be sure to check us out and keep it locked in with Twitch. All right, y'all. Have a good one.
Thank you. See you. Bye.